Hi, I'm Paul Battaglia, and this is section 8.5, Applications of Matrices. I've brought along Gabe and Brittany with me because there's just so much we could talk about in this section, and we thought it would be nice if we kind of walked you through some of the highlights. And I guess I'll start with Cramer's rule. We start the section off with Cramer's rule, and really the one thing I always like to point out to teachers and students is the misconceptions that come up and the common errors. And one of the things I see a lot is, let's say you're working with the variable x in Cramer's rule. I actually find that students incorrectly replace the columns. So let's say you're working with the variable x, and on the numerator you have d sub x. I find that they're not replacing, as they should, the column involving the coefficients of the variable x with the column of constants, and I think that's something I run into a lot. Brittany, talk to us a little bit about one of the other applications we can play with.
All right, so we can find the area of a triangle,
Right.
But with the formula, there's a plus minus sign right in front of all of it.
Students are going to wonder why that's there.
Yeah. So sometimes students think that it means that there are two different areas.
Right.
One positive area, one
negative area. We know we can't have negative areas, I like to just keep telling my students, if you get a negative, we're just taking the absolute value. But the only reason we don't make it the absolute value sign is because with the determinant,
we don't want students to be confused.
Confusing it. So that's why that plus minus is there.
Makes sense. Perfect. Gabe, walk us through some other things we could play with.
Sure, so there's plenty of cool things we can do with determinants, especially involving lines in the plane.
Okay.
So students may have already seen or know what it means for 3 points to be collinear.
Right.
But you can use this idea of a determinant to actually show that three points in the plane are collinear or are not collinear.
Okay.
And we also have this other 2-point form of a line that students can work with, and they can find it just using a determinant.
Yeah, which is pretty cool.
So they can do it by hand, talking about slope-intercept form of lines and point-slope forms of lines. But really, this is sort of a nice shortcut application of the determinant.
Yeah, hey, why do we use matrices, right? So perfect. Yeah. I think a great way to end this section, and you do need to leave yourself a little bit of prep time here, you can do a couple things. I'll start with the easier one, and that is, actually sometimes I've given my students, I've superimposed a map onto a Cartesian plane, for instance, and I'll say, let's take the 3 coordinates on this map. I know one of the things I like to bring into class sometimes is a map of like an old Revolutionary War battle or something. And when we do that, I ask my students to plot 3 specific points or look at 3 specific parts of that map and say, go find the area of that particular part of the battlefield. Just pretty neat, splices it up a little bit. And then this is one that requires a lot of preparation. That's the area of cryptography. I mean, you can really do some fascinating things. I mean, getting students to get lost in the idea of encoding and decoding messages using matrices is pretty awesome stuff. And just as a warning for teachers, it's not the kind of thing that you can just look at in 5 minutes and make happen. So if you prep it and you really want to go into it with your students and you think they can handle it, I think it'd be a great way to end the chapter on matrices. Hope you found these tips helpful and that you find much success in section 8.5.